we were just talking about confidence intervals. So above we have the formula. Anytime you've calculated a confidence interval, remember you're going to come up with some lower bound and some upper bound is what this is going to give you. And so our conclusion takes that bound and brings it into context. So we are blank percent confident, just like we've seen before, that the true difference in the proportion of blank and the proportion of blank is between blank percent and blank percent. So what is that actually talking about? Well, we have our confidence level in here. Whatever you chose your confidence level to be, that's how confident you are. That the true difference in the proportion of group 1 population, so the difference in the true proportion of men who drive and wear seatbelts, or the true difference in the proportion of men who wear seatbelts and the proportion of group 2's population, so women who wear seatbelts, is between blank percent and blank percent. And so that would just be A and B, whatever our lower and upper bounds for the confidence interval are. Okay, so if we turn the page, we've got our first example. So first example, college students were randomly selected and asked how much alcohol they consumed on a weekly basis. Over a certain amount of alcohol consumed was considered binge drinking. So of 5,348 males surveyed, 1,392 were identified as binge drinkers. Okay, and so out of 8,471 females surveyed, 1,748 were identified as binge drinkers. Estimate the difference in proportions of males and female binge drinkers. There shouldn't be a question mark there. And then we want to use 95% confidence. So let's jot all that down. So we see that our N1, and you know what? I'm going to change that notation up just a little bit. This is optional for you, but I think this helps with just the different formulas. So the sample size for males, N sub N, N sub M, it's hard to say, is 5,348. The amount of males we saw that reported as binge drinkers was 1,392. So that means the sample proportion for males is 0.260. Okay, so we repeat that over here for females. So N sub F, that just says sample size for the female group, is 8,471. The number of females we saw was 1,748. That gives us a sample proportion for the female group of 0.206. Okay, so we want to estimate the difference. So let's go ahead and write that down. Okay, so we want to estimate the difference between these two groups. We can also think of this as estimating the difference between the proportion of males and the proportion of females. Okay, so just like we've seen time and time again, we have to check all those conditions. So the first condition we need to check, I apologize if you're going to run out of room like I am. First condition we need to check is, are these two groups, was this sample of 5,000 males independent of this sample of 8,000 females? Well, is it possible that there are some siblings on campus, or maybe some married couples that are still attending college? Well, yes, absolutely, but we can't really show that every single individual in the male group is independent of every single female in the female group. So we just kind of look at, were they both selected randomly? Then yes, we can assume they're independent of each other. Assume female group and male group are independent. Okay, and from here we just check the other conditions, but we check them twice. So SRS for males was stated, that they were randomly selected, and SRS for females was stated. Okay, step 2. So step 2 is our success failure condition. So I want to know, in the group of 5,348 males, would I have seen at least 10 of them identify as bin shrinkers? Well, yes. We see that pretty clearly. And then I want to know, in this group of 5,348, would I see at least 10 that were not bin drinkers? And the answer to that is also yes. So that's been met. Now I just have to check it for females. So in the group of 8,471, we would see at least 10 successes. And in the group of 8,471, we would see at least 10 failures. So that's been met as well. Okay, and lastly, I know I'm blending into the plan step. Hopefully you're writing smaller, but the third one is just, have we stayed under 10%? And so for this third one, all we have to say is, there are more than, we're basically just taking 5, 3, 4, 8, so adding a 0. So have we stayed under that number? So have we stayed under 10%? Yeah, there are more than 53,480 male college students. And there are more than 84,710 female college students. Okay, so conditions have been met. So the distribution is approximately normal. Okay, so our plan step we've got to state the type of test we're running. Or not a test, I guess. We'll get to the test. But this is going to be a 2 proportion Z interval. And this is critical if you choose to use the calculator, which once I show you the calculator, I'm willing to bet all of you will prefer that route. So for the do step, the plan step, we can include a picture. I've been asked estimate the difference in proportions at a 95% confidence level. So 95% confidence level, if we're drawing our picture, looks like this. Okay, so we need the sample difference and then I need plus or minus the z star times the standard error. Okay, and so this sample proportion difference gives us 0.054 plus or minus. If you're not sure how to find the critical score yet, we come back up to this picture and we ask how much is underneath this lower tail. Turns out that it's 2.5%, and from there we do inverse norm in our calculator. If you're still struggling with that step, come see me, or maybe you've memorized it and we know that for a 95% confidence level, the z star is 1.96. Okay, so for this, it's 0.26 times 0.74 all over 5348. That's how many males were sampled, plus 0.206 times 0.794 all over 8471. This will be the only time I have you go through this by hand. We'll see that this do step can actually be done a lot quicker using the calculator. So we should end up with, again, you'll probably need the sub to pause, but just have him do that. You should end up with 1.96 times 0.007 is the standard error. So this gives us a confidence interval of 0.040 and 0.068. Okay, well, what are these numbers? Let's talk about that in the conclude step. Okay, so we conclude that we are 95% confident that the true difference in the proportion of male binge drinkers and the proportion of female binge drinkers is between 4% and 6.9%. Okay. All right, moving right along. Oh, that was the do and conclude step. I did that on the last slide. Okay, so for the calculator, this is why we've been so meticulous about listing x1, n1, x2, n2. So on your calculator, all you're going to do is go to, let's open up the calculator. Okay, so we are going to go to stat. We're going to go over to tests. And we're going to go to a 2 proportion z interval. We're going to pass a 2 proportion z test, which will come up in just a couple minutes. We're going to keep going until we see, too far, 2 proportion z interval. So that should be letter B. We'll select that. And here we are. So it's asking for how many successes did you see in the first group? Well, in the first group, we saw 1,392 males out of a total 5,348 males that were in our sample group. Okay, and then for the second group, we saw 1,748, and there were a total of 8,471 females in the sample group. Confidence level, 0.95. And this screen right here is kind of what you'd copy down to show your work. You would write 2 proportion z interval and then list the values you entered for each variable. Okay, so we'll press enter, and we end up with 0.039 or 0.04 if we're rounding, and 0.069, which is exactly what we came up with doing this by hand. And we'll see here it even gave us our sample proportion for males, which was 0.26, and our sample proportion for females, which was 0.206. All right, and so let's go back and we'll jot all this down in essentially what you would want to show for full credit. So for full credit, you would want to list X1 was 1,392, N1 5348, X2 1748, and N2 8471. All right, and then finally the confidence level as written in your calculator. However you choose to write it, C level is how we see it in our calculator. If you just choose confidence level or CL, that would be fine. And we saw that that was 95%. Okay, this was done. We did stat tests, then we did a 2 proportion Z interval. Okay, and so this 2 proportion Z interval is how you're going to get points. We saw that in the rubric for the last FRAPI. And so as long as it's included, you don't need to show the formula if you state what type of test you run. And then, of course, we would want to record our answer. So 0.039 and 0.069. And so whether or not you had rounded, you would have made the same conclusion in your conclude step down here. So if you'd rounded, you'd have kept it at 4% and 6.9%. If you hadn't rounded, you'd have just said 3.9%. And 6.9%. Either of those would have been fine. Just remember to show your work, and rounding should not lose you points. Okay, calculator is much, much simpler. If you are not convinced, I will convince you with more practice problems when I get back. But otherwise, the calculator is free to use for these problems. You do not have to go through this formula if you don't choose to. It's always an option, but the calculator is now, previously in the last chapter, I told you you could only use the calculator to double check your answer. But since the formulas have kind of gone up a notch in the difficulty department, you'll be fine using your calculator. Okay, so let's talk about 2 proportion Z tests. So what number, think about that, what number would I see in this confidence interval that would indicate there was no difference? Okay, so if there was no difference between the number of college students, between the number of male college students that binge drink and the number of female college students that binge drink, if there was no difference there, then 0% would show up in that confidence interval. So that's very important as we move forward with 2 proportion Z tests. Okay, so I'm going to go ahead and stop it here. This will be the end of chapter 21, part 2, and we'll just pick right back up for the next video.